All right, couple things to keep in mind is that you need to complete this accurately, showing all your work. And this is your ticket if you want to retake Chapter 1 test. Okay, number 1, it says which size of the soup shown in the table has the lowest unit price? Lowest unit price. Here's our y, there's our x. Remember, it's always y over x. We have dollars over ounces. And so if I go through all of these, dollars over ounces, we find the clear winner is the 10 ounce. Because it's only about 8 cents an ounce, and the others are more. So that is how you know which one has the lowest unit price. Okay, on number 2, this is the division symbol there. So we have 4/15 divided by 2/5. Well, that's the same as 4/15. And remember, we multiply by the reciprocal. And we can do some reducing. You know that 5 goes into 15 3 times. So now this is a 1, and that's a 3. Also, we can see that 2 will go into 4. 2 goes in there once, and 2 goes into 4 twice. And now we can just multiply straight across, and we have 2 times 1 is 2, 3 times 1 is 3. The answer is 2/3. Number 3, we want to know the average reading rate in pages per minute. Pages per minute. Here's the pages, and here's the minutes. So let's see, the pages is going to be 8 1/3 pages. I'll just put page, and that's per 10 minutes. Okay, well that's the same thing as, so that's 8 1/3 divided by 10. And that 10 is just like putting a 1 under it. So I'm going to use the times plus. 3 times 8 is 24, and 1 more makes 25. I'll then change the division to times because I'm going to multiply by the reciprocal. And then I can reduce some things. I know that 5 will go into both of these. 5 goes into 10 twice. 5 goes into 25 5 times. And so what am I left with? I'm left with 5 times 1 is 5, and 3 times 2 is 6. So the answer is 5/6 pages per minute. Okay, we're looking to solve for, we're looking to solve for x. Right there. And I'll do the long method on one side and the short method on the other. 2.5x is equal to these two, 4 times 4.3. All right, and then we would simply divide by 2.5, divide by 2.5, and that's what x equals. And you would use a calculator to solve for your answer. The shortcut method is simply to say that x is equal to, and notice whatever's diagonal of x goes on the bottom, and these two go on top. 4.3 times 4. And now we'd use a calculator to solve for the x. And that answer is 6.88. Of course, it says round to the nearest, 10th. The tenth is right here, so it'd be 6.9. On number 5, it says we have 6 bottles for $4. So we have $4, 6 bottles. And then we also have 18 bottles for $10. And the question is the cost of the water proportional to the number sold? Is it proportion? No. So as it turns out, if I take the unit rate, you will see that these two are not equal. Therefore, they cannot be proportional. Another way to look at it is that, let's see, 6 times 3 is 18. Is 4 times 3 equal 10? No. No, it doesn't. So that's another way to quickly check. So is it proportional? No, it is not. Count number 6. A table shows cost of ordering a certain number of pieces of chicken. What's the value of X if the cost is proportional to the number of chicken pieces ordered? Include units with your answer. All right, so here's the cost, and it may be hard to see, but that's in dollars. Excuse me. Okay, so I kind of drew it down below a little bit more clear, and this is in dollars. And notice that as you go along, each time you get another piece of chicken, it goes up $1.50. Every time it goes up $1.50. Right? Okay, well, most of you were looking for this. How much is that? 6 pieces. And if you notice up here, see that? Here's 4 and then a 6. There's no 5 in there. So many of you were trying to find this answer. Many people put down 750. Well, that's not what it's asking for. It's asking for 6 pieces of chicken. 6 pieces. So if you were to continue this cycle, you would find out that it would be $9. And you need a dollar symbol in there because it said include the units. So the answer was $9. And if you wanted to, you could even use unit rate. Or if you chose to, you could set it up as a proportion. $3 for 2 pieces, X dollars for 6 pieces. All right, and we just went over this, so this number would go on the bottom. The other two would go on top. That's 18 over 2. That is 9. So the answer is $9. Number 7, Bart can type 296 words in 8 minutes. And it wants to know how many can he type in 20 minutes. So it's good to put our units up so we know where the 20 goes. The 20 goes at the bottom. 20 minutes. And we're trying to figure out how many words. Eight's on the bottom. 296 times 20. And you had a calculator available to you? It should calculate out to 740 words. Okay, it's asking for the constant rate of change. So let's see. Meters per second. And this is, the meters is changing by 40, isn't it? 40 to 80 to 120. It's consistently changing by 40. And on the top, the seconds is changing by 10. So 40 over 10. Well, 40 over 10 is just 4 over 1. So it's changing by 4 meters per second. Okay, find the rate of change and include units in your answer. All right, so let's see. We have degrees, that's your y, and time is the x. And we want y over x. So let's see. How much is the degrees changing? It's changing by 4, right? 4 degrees. Whoops, sorry about that. 4 degrees. And then what else we have here? 4 degrees, and this one is changing by 2. 2 what? 2 hours. So 4 degrees every 2 hours. Well, you know what? That can be reduced to 2 degrees every hour. Okay, this problem you had one of these just like this in your notes. Same wording. All I did is just change a couple of numbers. So let's see here. At 1 o'clock, there were 14 seagulls. And at 3 o'clock, there was 46 seagulls. And we're trying to figure out the constant rate of change. Constant rate of change. So, how much did it change going there? Well, if you can't do it in your head, you would just subtract, and it's 32. That change is 32. And over here, the change is 2. So we have 32 seagulls every 2 hours. That's how much it changed. Well, if you reduce that, that would be 16 seagulls per hour. That is the rate of change. That's how much it changed. Number 11, it wants to know the constant of proportionality. Okay, so let's see here. We have, which is just the slope, y over x. But first, notice that we have to figure out where they meet at, where the line, where it makes these intersections at, where the line goes through there, the graph line. And notice it goes at that point. It also goes through at this point. These are nice, easy numbers for us to detect. So you see that there? Oops, excuse me. Okay, so any one of these 3 points will suffice. They'll work for us. For example, I have 6 over 2, right? This is 6 pounds of meat, and this is for 2 people. I'll just put a P for people. So that means it's down to 3. It's 3 pounds for 1 person. That is a unit rate. And it works the same thing with 12 over 4. That's also 3. Or 18 over 6. That is also 3. Number 12, we need to write the equation for that last graph that we saw. And if you remember, this is where our unit rate goes, or our constant of proportionality, and that number was 3. So it's y equals 3x. Number 13, Selena babysits on weekends. This is the equation we have. Y equals 12x. The amount of money she earns for x hours she babysits. It wants to know the constant of proportionality. Well, the constant of proportionality is this right there, 12. The answer is 12. Number 14, we have 345 feet per 1 minute. And we're trying to convert it into feet per hour. So notice, I already have feet there. So I don't need to change the feet. The only thing I need to change are the minutes. So let's see, I'm going to just multiply. And remember, I'm going to need minutes up on top. And I want to convert it into hours. Okay, so we have minutes, and then we have hours. And we know that there are 60 minutes in 1 hour. Notice that the units, the minutes and the minutes, cancel. And look at what units I have now. I have feet per hour. Feet per hour. All I have to do now is just use a calculator. And it's 2,700 feet per 1 hour. Number 15, we have 15 gallons of gas to drive 330 miles. All right, so let's see, gallons per mile, or miles per gallon, so I'm going to use miles per gallon. And 15, I'll put the units in here. This is miles, and this is gallons. And that means my units are going to have to be, it's got to match up, miles and gallon. This will help tell you where to put the 20 gallons at. And the 20 gallons goes at the bottom. So you want to know how many miles it is. So let's see, x equals, remember the one diagonal goes at the bottom. Excuse me. And the other two go on top. You use a calculator. Your answer should be 440. What we're looking for again? We're looking for miles. That's how far you can travel on 20 gallons of gas. Last problem. It says a fox can run a speed of 42 miles per hour. And how many feet per second is this? So we're going to want feet per second. So we're going to have to change a lot of units here. So let's first get rid of the miles. Okay, so we have miles. And we know that there's, so we have feet and miles. And we know that there are, let's see, is it 5,280 feet in 1 mile? Okay, so right now we already took care of the miles. And we have feet. That's what we want on the top. Now let's take care of the hours. So looking at the hours, we want to change hours into seconds. Well, let's see. We know that in 1 hour, I need to have hours at the top, so they'll get rid of each other, cancel. So we know that there are 60 minutes in an hour, right? So I can put that in there. There's 60 minutes in 1 hour. Okay, so let's see. That takes care of the hours. Now we just have minutes, but we want seconds. We want seconds. So it looks like I'll have to do this again. I know that in 1 minute, there's 60 seconds. 1 minute, there's 60 seconds. And if you notice the units, minutes and minutes, they're gone. So now I just have seconds, and that is what I want. So now it's just a matter of calculating. So I'll write that out for you real quick. It's going to be 42 times 5280 divided by 60 divided by 60, and you should be able to get your answer. And the answer is 61.6 feet per second. Congratulations, you made it through this long video.